Okay, in this video, we're going to learn how to solve projectile motion problems. So the first step in solving a problem is to draw a picture. You want to draw your X and Y axes, and you want to draw the trajectory of the projectile. You probably also want to include the initial velocity. The next step is to define your reference point. Where your 0, 0 point is in the problem will determine how you put your numbers into the boxes to solve for whatever unknowns you have. The next thing you want to do is break your vectors into components. If your vector is not parallel or perpendicular and there's an angle given, you need to break it into components. Next step is to substitute them into the boxes. Remember, in uniform motion, we had our boxes which had our initial and final position, our initial and final velocity, acceleration, and time. We're going to do the same thing, only we're going to have a set for the X direction and a set for the Y direction. Next, we're going to use our kinematic equations to solve for any unknowns. A stone is thrown horizontally at 35.0 meters per second east from the top of a cliff 44.8 meters high. How far from the base of the cliff does the stone strike the ground? Compare and contrast the final velocity, acceleration, and total displacement in this problem with that of the same stone in free fall. Okay, so the first thing we want to do is draw our picture. So what I'm going to do is draw my picture. Notice I have my X and Y axes. I've drawn the trajectory of the projectile, and I've drawn my initial velocity. If you need to pause the video, go ahead and do so. The next step after we draw our picture is to define a reference point. I'm going to choose my reference point to be here at the origin. So I'm going to make this 0, 0, right there. Okay, the next step is for us to break our vectors into components. This is a little bit tricky. So you have to write out each vector in I hat, j hat notation. Unless you've had math analysis, you may not know how to do this. So what I'm going to do is I'm going to walk you through it. My initial position, and I'm going to use D for my initial position. If you look at my picture here, my initial position is at 0 in the X direction, but it's at a height of 44.8 meters in the Y direction. Okay, so I have two different directions here. So I'm going to have 0 meters I hat plus 44.8 meters J hat. Okay, notice how I have I hat plus J hat. Okay, the next thing is our final position, D final. Well, we want to know how far from the base it lands. So this is a question mark right here. We don't know what the final position in the X direction is going to be. But we do know that we land on the ground in the Y direction. So that's going to be at the origin for the Y direction. Okay, next we have to do initial velocity. My initial velocity is going to be, if I look at this, it's 35.0 meters per second I hat. And notice I'm only going east to start with. See this? It says east. I'm not going south or north. So I'm going to add, oops. I'm going to add 0 meters per second J hat. For my final velocity, I'm still going 35 meters per second east because there's no acceleration in the X direction. We assume for projectile motion there's no air resistance. Here, though, I don't know what my final velocity is going to be at impact. Okay, so if you look at the picture here, right here at this point right here, I don't know what my final velocity is going to be at impact. I know after impact it'll be 0, but I don't know with what velocity it hits at in the Y direction. So I'm going to add a question mark because I don't know what that is. Okay, next I need my acceleration. Okay, acceleration in the x direction, I'm not accelerating at all. You can just memorize that. You're never accelerating in the x direction unless there's air resistance. And in the y direction, it's always the acceleration due to gravity. Now I'm ready to substitute into the boxes. What I'm going to do is I'm going to have two sets of boxes. Okay, I'm going to have a set for the x direction and I'm going to have a set for the y direction. I'm going to pause the video at this point so that you can go ahead and get your information, get your boxes straight. Okay, so here you can see your boxes, and what I'm going to do is I'm going to write in my information. I'm going to put my initial position, my final position, initial velocity, final velocity, my acceleration in the x direction, and time. This is all for x. If you want to put x initial and x final, you can do that. I don't like using x and y because it right away makes you think of math instead of thinking of displacement or position. Okay, so in the y direction, I have d initial, d final, v initial, v final, g, and t. Notice there's no vector sign on the t. Okay, now what we're going to do is we're going to go back to our previous page here. Actually, two previous pages. Okay, and I want to show you something. Notice how we've written our each component or each variable as a vector quantity. We've written it with an I hat and a j hat. So here's what I want you to do. If you take a line and draw it straight down, well, that way, okay, you'll see that you have all I hats on the left-hand side and all j hats on the right-hand side. Well, here's the thing. All these I hats fill in your boxes in the x direction. All the j hats over here fill in your boxes in the y direction. Okay, so for the first box for initial position, we have 0 meters I hat, and here we have 44.8 meters j hat. For our final position, I'm going to try and thin this up a little bit. There we go. We have 0 meters, 0 meters j hat. I'm writing with my finger, so excuse me. Here's a question mark. We don't know what it is. The initial velocity here is 35.0 meters per second I hat. It's the same for both directions, so I write it right across the boxes. We know that this is 0 meters per second squared I hat. Are we given the time? No. Okay, now in the y direction, am I given the initial velocity? Yes, it's actually 0 meters per second j hat. My final velocity, unknown, not given. G is negative 9.8 meters per second squared j hat. And time, I don't know. Okay. Okay, now we have a problem here. We have two unknowns in the y direction and two unknowns in the x direction. Now you may be thinking that that's okay. We'll just solve for this initial or final position by ignoring time. But what you're going to find if you do that is you're going to get 0 equals 0 every single time. So we need to solve for time in order to get rid of that 0 equals 0. In order to do that, what we're going to have to do is we're going to have to solve for time in the y direction because we have enough information in the y direction to do that. Okay, so what I'm going to do now is I'm going to go ahead and solve for time in the y direction. I don't have a final velocity, so I'm going to be using delta D is equal to VIT plus 1/2 gt squared. Okay? I'm going to be solving for time. This is nice. Look at this. The initial position or the initial velocity is 0, so that drops out. Okay? Solving for t, t is then equal to 2 delta d over g, and I'm going to take the square root. Okay? If you need to understand what I just did, or you don't understand what I did, and you're unable to figure it out, I need you to go ahead and make a little note in your notes for me, and then make sure you ask me questions in class next class. Okay, so we're going to substitute in our numbers. We have 2 times, let's see, it's final minus initial. So I'm sorry, it's going to be 0 meters j hat minus 44.8 meters j hat divided by negative 9.8 meters per second squared j hat. Notice here that the negative in the numerator and the negative in the denominator are actually going to go away, which is good. Oops. Which is good because we don't want to have a negative in the square root. It ends up giving us an imaginary number. Okay, so what we're going to do is go ahead and get your calculator out. Okay, I'll be honest, I don't have a calculator, so I'm going to have to use my computer calculator. Sorry, you're going to have to see all my facey stuff. There we go. Oh, there we go. I need scientific. Okay, so what I'm going to do is I'm going to take 2 times negative, where is, here it is, 44.8. Okay, and then I'm going to take that and divide it by 9.8 negative. Okay, and that gives me 9.14, and then I'm going to take the square root of that. And that gives me 3.02 seconds. Now, looking at my numbers, 2 is a counted number. Negative 44.8 is measured. That's 3 significant digits. Negative 9.8 meters per second squared j hat is a constant. It doesn't count towards significance. So my answer has to have 3 significant digits. So my answer is going to be 3.02 seconds. Now that I know the time, I can go ahead and solve for my final position in the x direction. Okay, so what I'm going to do is I'm going to use that 3.02 here. Okay, so one thing I need to do is I need to make sure time is in my equation. I also need to make sure that displacement's in my equation because that's what I'm solving for. So there's 2 things I can do. I can cross out A, or I can cross out V final. I cannot cross out V initial. You have to have that in every equation. So what I'm going to do is I'm going to go ahead and cross out the V final, and I'm going to use delta D is equal to VIT plus 1/2 AT squared. Now I'm on the left-hand side, which means that I have a subscript x for everything. So just understand that this is actually in the x direction. Okay, so here's the nice thing though. This term goes to 0 because my acceleration, as you can see, is 0. Okay, so I end up with delta D is equal to my initial velocity, which in this case is 35.0 meters per second I hat, times the time, which I calculated to be 3.02 seconds. Okay, now I'm going to get my calculator out again. 3.02 times my 35.0, and that gives me 105.7. Now I need to make sure I have the right number of significant digits. I only need 3 significant digits because I have 3 in 35.0 and I have 3 in 3.02. So my final answer has to be 106 meters I hat. Okay? So there you go. That's how you solve a half projectile. In other words, if you're throwing something off a cliff, this is the perfect way to solve the problem.